Hi, and welcome to Lesson 9 of our Compounds unit. Here in Lesson 9, we're going to continue our mathematical relationships among compounds and formulas by talking about percent composition. Percent composition is simply the percentage by mass of the elements that comprise a particular compound. Reference table T actually has the equation for percent composition. It's simply the mass of the part that we're looking at divided by the mass of the whole compound times 100. Let's try a percent composition problem that's not actually in your packet. So in this problem, you're going to need to determine the percent composition of magnesium in the compound magnesium nitride. Pause the video, try it on your own, and then when you're ready, let's go through it together. Cool, so let's see how we did this. The first thing that we needed to do is, of course, use our percent composition formula. It's going to be the mass of the part divided by the mass of the whole times 100. Substituting in our values, we get a value of 72.9 AMUs for the total mass of magnesium in the compound and 100.9 AMUs for the total mass of everything in the compound. We're then going to do this math and multiply it by 100, and what we're going to wind up with is 72.2%. If you don't understand how I got either of these, you should probably go and re-watch our discussion on formula mass from our previous lesson. One of the common situations in chemistry that deals with percent composition involves hydrates. Hydrates are a special kind of solid crystal that traps water molecules inside of the crystal lattice. The typical way we write a hydrate is to write the formula of the hydrate, which I've represented here as XY, and then a dot with some number of water molecules afterwards. It's important to understand that it's not a multiplication sign, it's just a convention for writing the formula. We can remove the water from the hydrate, at which point we would just have the anhydride, or the non-hydrated version of the hydrate, which would just be represented as XY. Here's an example of a hydrate. This crystal is cobalt 2 chloride hexahydrate, which has the formula CoCl2 with that dot, and then 6H2O for hexahydrate. This is the anhydrous version of cobalt 2 chloride. We've removed the water from it. My question to you is, how do you get from one to the other? How do we go from the hydrate to the anhydride? Take a moment and see if you can think about the answer before we go to the big reveal. So the answer is that we just simply heat it up. We take the initial mass of the substance, we heat it up thoroughly, we take the final mass, and then the missing mass would be that water. That water would have been caused to evaporate due to the heating, and we'd be left with just the anhydrate. You have an image of the typical hydrate heating apparatus on page 17 in your Unit 7 packet. Let's look at a hydrate problem. This is on page 18 of your Unit 7 packet. A 10.40 gram sample of hydrated crystal is heated to a constant mass of 8.72 grams. Calculate the mass of the water that was driven out, and then calculate the percent by mass of water in the hydrate. Pause the video and try this on your own, and then when you're ready, we can go through it together and look at the solution. So let's do the first part first. The mass of the water is going to be equal to our initial mass minus our final mass. That lost mass is equal to the water that was driven out of the crystal. 10.40 grams minus 8.72 grams gives us a total mass of water of 1.68 grams. Now that we know that, we can do the second part of the problem. The percent composition of mass of water in the hydrate would be equal to the mass of the water divided by the mass of the hydrate times 100. We're just going to substitute in our values, 1.68 grams divided by 10.40 grams. Notice that we're using the preheated hydrate mass here because we're interested in the mass of the whole, not the mass of the anhydride. 1.68 divided by 10.40 times 100 is going to be equal to 16.2% to the correct number of significant figures, which is what I'm recording as my answer here. Does that make sense? If it doesn't, take a moment and write down any questions that you have before we move on. Thanks so much for watching this video on percent composition. Take a moment here at the end and make sure that you can do the following. Make sure that you can determine the percent composition of any element in any mass of any compound. Also make sure that you can determine the percent composition of water and anhydrous hydrate based on the formulas of the hydrate and experimental data from hydrate heating. If you can do those things, you're doing great. If not, that's okay too. Take a moment and write down any questions that you have. You can always leave a comment below the video or get in touch with me through the information in the info field. Thanks again for watching. I really appreciate it. Have a great day.